Hi, welcome everyone to Innovation Flow Podcast, a podcast where we talk about PARC projects and initiatives, and we're going to do that today with Shannon Harney, my guest for today. Welcome, Shannon.
Thanks, Blair. Happy to be here.
Yeah, I have you on because we wanted to talk a little bit about a project you have been instrumental in, and I wanted to learn a little bit more about this LAWS project. So before we get into that, can you introduce yourself, who you are, what you do on your free time, that kind of thing for the viewers?
Yeah, absolutely. My name's Shannon Harney. I'm an asset engineer 2 here at SPR. I've been here for almost 4 years now, which time flies because that was seemed like not that long ago. But I mainly work on our asset management program, developing and implementing that, as well as capital projects, pilots, which I'm excited to talk about today, as well as our sustainability and energy efficiency programs. I joined SPR right out of college. I graduated from Colorado State University.
Go Rams.
Go Rams in 2020 with my bachelor's in environmental engineering. And then all through college, I worked a lot in the field, doing a lot of ecological research. I worked all through Colorado, Wyoming, a little bit in Alaska, so I was really excited to kind of carry that research through to this position. In my free time, I'd say I'm a pretty typical Coloradoan. I love to go snowboarding now that it's in the winter, get up to the mountains as much as I can. I also love reading, have a huge, list of books that need to be read this year. And yeah, that's pretty much it.
Cool. What kind of reading do you like? What kind of books are you usually reading? Fiction, nonfiction? What are you into?
A lot of fiction. I really like fantasy. Anything with like an adventure. More books in a series, the better. The one I'm reading right now is about 8 books that I'm about halfway through.
Cool. All right. Well, I don't know if I introduced myself. I'm Blair Corning. I'm Deputy Director here at South Platte Renew. And so let's get started. First question, if you weren't an environmental engineer from CSU, what do you think you would like to be? What profession would you choose?
I was thinking about this lately because I actually read a book on something similar, but I would love to be an anthropologist, like really being able to study people's cultures, why they do the things they do, and also be able to travel to some pretty cool places.
Yeah, that would be cool. That'd be a dream job there.
Yeah, right?
Yeah. All right, but you're a wastewater engineer, and that's exciting too, right?
Mm-hmm, absolutely.
It's partly exciting because of projects like this LAWS thing that we're here to talk about. So why don't you give us a little overview of high level, what is LAWS, what's the project, and what's it all about?
Yeah, absolutely. So the LAWS pilot came about in about 2019. We're trying to solve this problem where due to regulations in our discharge permit, we've got to get rid of nitrogen in the wastewater. And the last step to do that is our denitrification filters. But in order to remove that nitrogen and promote that denitrification, we've got to add carbon. And so to do that right now, we add methanol, which in recent years has increased in price. It's very carbon intensive because it's derived from natural gas, oil, coal. And we wanted to find a way to kind of do this process more sustainably, still meet those effluent regulations, but remove the methanol. So we started looking for this external carbon source, and we really targeted the brewery and distillery industry because these are 2 industries that are generating this high alcohol content, high carbon content product. But during that distilling and brewing process, they're also creating these waste streams that for them it's actually kind of a burden to get rid of because they are so high in carbon, because they do require either trucking or special disposal methods that's really costly to them. So we ended up partnering with LAWS Whiskey House, which is actually just up the road here off of South Broadway, and started taking their waste streams. There's 2 streams, one of which is called stillage, one of which is called their heads, and actually using those as a carbon source a little further up in the plant at our solids contact tanks. So we had them truck in that waste product. We have a pilot dosing skid here on the facility where we dose into the solid contact tanks and promote denitrification in those solid contact tanks. That way, we were removing that nitrogen upstream. We wouldn't need to use as much methanol, and kind of create a more sustainable process.
So when they're doing their thing, they're distilling distilling the alcohol, and as part of that, you're saying some of that is wasted, but it's valuable to your wastewater process because of the high carbon.
Yeah, absolutely. So when there's two different spots of the process where we kind of get that waste off. The first is in their stripping still, where they actually add all those grains, they add the alcohol, and they heat it up, and they take, the good alcohols, the ones that taste good, and the ones that go into
Those
whiskey.
are the ones I'm familiar with.
Those are the ones most people are familiar with.
But the bugs will eat the other kind.
Yeah, so all that other stuff that comes off that's gonna, make your whiskey taste bad, those got to be taken out of the system. But those are actually really beneficial for us because those are still high in ethanol, really high in carbon content. And then a little bit further down, when they're in the actual still and they're pulling off that grain alcohol that's going to be put in the barrels to make the whiskey, the first, couple minutes pulling off the machines, they get what they call our heads, and they're really, really concentrated. It still has that high alcohol content, but again, it's those alcohols that don't taste good that are kind of going to mess up their formulas, so they have to waste them essentially to get to the hearts, which is the true alcohol that they want.
The stuff that'll make you go blind there.
Yes, yeah. We did learn on a tour once that if you were to drink some of these heads, or even the stillage, you could potentially go blind, which is not what you want in your whiskey.
Yeah. Well, it's interesting that you targeted distilleries, breweries, because I know Colorado is big on both of those. There's a brewery, seems like every block or two, which is a total Colorado thing. So that's good. Can you talk a little bit more about the sustainability aspect? What the benefits would be to using this waste rather than the methanol that you're currently using?
Yeah, absolutely. Like I had mentioned, methanol is derived from the oil and gas industry, pretty much mined from fossil fuels. So it's really carbon intensive. It can have a lot of carbon emissions along with it, as well as the trucking costs. I mean, we get a methanol delivery every week, if not every other week, and having that delivered to site is also adding to some of those carbon emissions. So being able to reduce those emissions from generation and transportation of the methanol would really go a long way for increasing SPR's overall sustainability. And I think the bigger part here is really promoting that circular economy, like taking something that is a waste and really a burden on one industry to get rid of and beneficially reusing it at our facility in a way that, I think it also increases resiliency. It helps us meet future regulations. So it's really a win-win on both sides.
Cool. Can you get a little more in-depth? So you take the stillage, the heads, the waste from the brewery, you bring it to a tank here, and then you said you put it in an aeration basin. Can you get a little more in depth on what's going on in that aeration basin?
Yeah, absolutely. So the denitrification process is when nitrite and nitrate are then converted to N2 gas and emitted off. But to promote that process, you've got the bugs involved that are already there in the basin, but they also need a carbon source. They need something else to give them energy to eat up that nitrogen in the wastewater. But based on our process, that carbon's already been removed in the trickling filters. So we're taking this external carbon source, the stillage or the heads, we're dosing it into the basin. We're also shutting off the air. The denitrification process typically needs an anoxic, so little to no oxygen in the environment to be performed. So we turned the air off. We've got those bugs already in the wastewater. We've got the wastewater itself. And then while we're adding that carbon source, it creates that perfect environment for those microorganisms to really just go to town and eat all of the nitrate and nitrite and really help that chemical conversion happen a little bit faster.
Cool. Well, that's interesting. What are some of the challenges that you came across in implementing this whole project, and maybe give us a timeline of how long it took to set up and perform the experiment, and then some challenges that maybe you ran into along the way?
Yeah, absolutely. We began this pilot all the way back in 2019. That's when we had first started talking to laws and trying to get that pilot set up. We had an initial pilot set up that we ran into a lot of challenges with, actually. It was really just a couple of totes, some small pumps with some piping into the basin. It was kind of a temporary setup, but we thought it would suffice for the time. But as soon as winter hit, we realized it was kind of going to be an issue. We saw some freezing. The stillage also actually, because like I said before, it's the water that comes off the solids the grains that they're using. There is a bit of the particulate matter still in the wastewater, or in the stillage. And so the pumps were having a hard time, pumping through with those solids in there. So we kind of paused it in 2020. We also, laws let us know that they were actually moving their distilling location, so they stopped producing waste for a little bit. So we had kind of a pause. We spent some time really investigating, designing, and installing a brand new pumping skid with a more permanent pump system. It had heat trace, it could handle the solids, a little bit more appropriate for the application. So we started the pilot back up in August of 2023. We started taking deliveries from Laws again. And I think one of the biggest challenge with this pilot, and especially if we wanted to expand it or go full scale, is availability of the waste product. Just due to the nature of the distilling industry, sometimes they're producing a lot, sometimes they're not producing at all, based off industry trends, based off if they have to do maintenance. So we actually ran into a couple times during this second phase of the pilot in the fall and winter of 2023 that Laws just wasn't producing. They were either down for maintenance, or actually in the beginning of 2024, they cut production in half just based on consumer trends. People weren't drinking as much whiskey. They had a lot of back product that they kind of had to go through. Young people aren't drinking as much anymore. The post-COVID, they saw a post-COVID spike. Everyone's excited to be go back out to dinner.
Yeah.
And I think they saw a level off from that. Kind of decreasing.
Yeah, but the bacteria at the plant, they don't go on break, right?
No, they never go on break.
You've got a steady need for it, and part of the deal is they producing that product steadily is an issue. Huh?
Absolutely, yeah. Ideally, we're running this process consistently. We're getting deliveries every day from Laws, or potentially another distillery, if we wanted to partner with others, and so that we can be dosing consistently. But yeah, we just didn't see that in the last round of the pilot, and so that was definitely one of the biggest challenges.
All right, what else did you run into? How was it working with these whiskey folks, these whiskey distillers, who are in a totally different, a little bit similar but different industry than Wastewater? How was your experience working with them?
Yeah, absolutely. I mean, the Laws folks were amazing. It's part of their core values as a company to incorporate water conservation, sustainability, and really anything that protects Colorado's waterways, because they know that's critical to their industry as well, getting clean water to produce the whiskey that everyone loves. So they were really amazing to work with, and I think that's one of the reasons we kind of picked them in the beginning, because their company really aligned with what we were looking to do. So yeah, they were a really great partner. They were very easy to work with, excited to really get through this. They actually bought a tanker truck. It was previously like a water delivery truck to actually bring the stillage to the site, and was dedicating a driver to deliver it to site. So they were really great and accommodating, and even now that the pilot's paused again while we kind of rethink next steps, they've been absolutely thrilled to work with us again.
That's good. Yeah, it's good to hear that there's companies out there that have some that dedication to sustainability and want to reuse things that normally just get thrown away as a waste product to the dump or to the wherever it goes.
Yeah, absolutely.
All right, cool, Shannon. Well, I want to take a little break here, and we'll get back to the pilot project here in a minute. But one thing I know from distilling, or at least whiskey in general, is when they barrel it, there's a certain amount that is lost right off the top to evaporation through the barrel. I mean, the barrels are watertight, but it still evaporates out of the barrel. That's called the angel's share in the whiskey world. So I want to know if you have anything in your world, in your life, that is lost right off the top. What's your angel's share, if there's anything in your world?
Yeah, Blair, the first thing that comes to mind is, when you go to do laundry, there's always two socks there. You put all your clothes in there, there's a pair of socks, two socks to every pair, and then somehow when you take the laundry out of the dryer, there's only one sock. I don't know where it goes. You never see it again. It's just lost right off the top.
That's the angel share. That's a good one. I think I and probably everyone out there has experienced the angel share of socks. But I was trying to think of an answer to that one myself. And only thing that came to mind when I was thinking was like when you go to buy a car at the dealership, you automatically are going to get taken for like a certain amount right off the top, right? Before you even worry about what kind of car you're going to, you're going to get that angel share that goes. It's more of a dealer share, I think, a salesman share, but yeah. Cool. All right. Well, let's get back to the pilot project here a little bit. So what you mentioned next steps, you said the pilot project worked. What data did you gather and what did you learn from that data as far as informing those next steps?
Yeah, like I said, we had some challenges getting, consistent product, being able to run the pilot consistently. But we were able to, for a period of about 2 weeks in February of this year, actually run the pilot steadily. And we did that with mostly heads. So like I said before, that like really high strength product that's coming off when they're actually pulling the whiskey off. And when we started running at a higher dose with those heads, which have a much higher carbon content, because we were measuring carbon on every delivery, we actually saw denitrification almost immediately. It was really. I remember I was at a conference at the time, so I was like texting operators, and it was really exciting. Everyone, could see really quickly in our data that we were experiencing denitrification, and that nitrogen was coming down in the basin. So yeah, it was really excited to see. I think it was really positive to see success in what we were trying to get to. We had this hypothesis that we could potentially use this external carbon source, and we weren't able to do it consistently, but we were able to prove that it is possible. Yeah. Which I think gives a lot of hope for next steps. And so kind of what we're working on now is really expanding the partnership. That way, if Laws or any other distiller ramps up, ramps down production, is down for a week, we've got other sources of that product coming through. So I've talked to, actually met with the Colorado Distillers Guild, which is a really great group, just kind of brings together it's kind of like an industry group for distillers, that connected me with a lot of local distillers in Denver, surrounding the Denver area that were really interested in potentially contributing to the project. So either giving us their stillage, giving us their heads, or both. I've talked to another larger distiller in the Denver area, trying to set up something consistently. Cool. So yeah, we're working on building the partnerships. We'll do another round of kind of what we call jar or bench testing. So we'll take a small sample of the wastewater, a small sample of these new distillers' waste product, and kind of test it in the lab at a bench scale before we go full sale. And yeah, interested to see different things in future rounds of the pilot if we can run it longer. Hopefully seeing some of those reductions in methanol usage. Also, we've always been interested in if different whiskeys have different carbon contents, if they're making a rye whiskey, if they're making a bourbon, if they're making a scotch, is one of those better? Do the bugs like those better? Trying to see if there's any kind of preference or difference there.
Cool. Well, you mentioned monitoring, that you were at a conference and you got results back, or talked to the operators, had results. Take us through a little bit of that. How do you monitor? How do you monitor? You said you're looking at the nitrogen species or the carbon. How is that tracked? How soon do the results come back? Where do you get the results from? Take us a little bit through the monitoring process of this whole thing.
Yeah, absolutely. I mean, this pilot was a full team effort. We had cross collaboration between operators, mechanics working on the pump, the lab staff doing some extra samples for us. It was really a full team effort. And that kind of spanned where we were getting our data from. So like I'd mentioned, we were taking carbon samples from each delivery coming in from Laws. That way we could understand, what was the strength of the product that we were putting in. And then we also have a lot of automation and process process sampling built into the plant already. So we had nitrate probes at the influent and effluent of the basin we were using, SET1. It was already set up. It was already capturing that data. We actually worked with our data and regulatory group to create a dashboard to quickly see increases or decreases, or see that change throughout the basin. So it was really just kind of capturing data that we were already capturing, but bringing it into one source to be able to see it specifically for this pilot. We also looked at, because one of the big things we wanted to consider was overall impacts to the plant. You know, we're zoomed in on the solid contact tanks and seeing if we can denitrify there, but we want to make sure that there's no major impacts to the rest of the plant. Yeah. So we kind of zoomed out and looked at nitrogen flow throughout the plant. We also looked at phosphorus, which is another thing we're regulated on. We looked at pH, wanted to make sure we weren't putting anything too acidic or too basic of the product into the basin. To kind of look at some other stuff, we looked at DO, because we needed that anoxic environment, so making sure our oxygen is low enough to really, just get a full picture.
Did you ever run into any issues with a laws truck coming into the facility through the gate there? Any public saying, what are you doing over there? What are you guys doing? But seriously, how has the public or your governing board, how have they felt about the project, or have they been supportive?
Yeah, absolutely. I think they see, if you can, show a monetary benefit that we can save, a certain amount on chemicals, they're really hopeful about that. And I think I've presented to them a couple times about the results of the pilot, and they've been very supportive, of course, of the sustainability initiatives. But methanol is also a super, harmful, flammable chemical. So if we could potentially reduce the need for that on site, that increases employee safety, kind of eliminates another risk that operators and other staff have to deal with on site. So they've been really excited. I think the concept that you can use whiskey to treat wastewater is cool for anyone. It's cool for me, but anyone I described the pilot to, especially our approval board, has been pretty, shocked and then excited about it.
Yeah, it is a cool project. Did you ever think you'd be doing this kind of stuff when you were in school? Did you think you'd be here?
Definitely not. I never thought I would be going to, a distiller after work, the owner of a distilling company, as part of, being an environmental engineer. So I think it's one of those projects, I've got to work on here at SPR where I'm like, this is what an environmental engineer does. It's not what you think.
Yeah. Well, good. I'm glad you were able to be on this show. This is interesting stuff, and I'm glad you were here to break it down for us and make it understandable. Share a little bit of the results of the project with us. So thanks.
Yeah, absolutely. Thanks for having me, Blair.
But it's not over yet. We have a end of show activity here. So I have a list of, and don't overthink this now. Don't overthink this, but these are a list of words. They're outdated. They're old. They're obsolete English words.
Okay.
So I'm gonna give you a word, and you tell me what you think it might mean.
Oh boy.
And we'll see how close you get.
Okay.
All right. Just the first thing that comes to mind when I say the word. So the first one is scurryfunge. What is scurryfunge? What do you think that means?
Scurryfunge. It sounds. The first thing that popped in my head is like a squirrel, scurrying around. Funge, I don't even know. Maybe something with mushrooms. So
a squirrel gathering mushrooms.
Squirrel scurrying around to gather as many mushrooms as he can for the winter.
All right. Yeah. I like that one. That's interesting. You're close. It is, and people are probably doing this over the holidays, but it's to frantically tidy up before guests arrive. So I guess it could be a squirrel collecting mushrooms.
Yeah, maybe he's trying to clean up his little, tree house before the winter.
All right, our next one, tell me what you think chork means. CHORK.
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 Chork. All I can think of is, it's too similar to a cork. If you're going to chork something, you're going to put a cork in it. You're going to stop it.
All right.
I'm thinking it's a verb.
Yeah? You think it's a verb? Okay. Mm-hmm. Well, it is kind of a verb. It is the act of making the sound your shoes make when you're walking in them and they're full of water. That's chork.
See, I think of that as a squelch.
Yeah. I would say squelch too. Mm-hmm. I guess it used to be chalk.
Okay.
Yeah. All right. We got a couple more here. What do you about crapulence? Being a wastewater engineer, maybe this one you might actually know this.
It sounds like, all I can think of is like a gold toilet. Like crapulence, like it's like opulence or like something like really nice, but also,
also toilet related. Yeah, all right, that's good. Yeah, these are you have a very logical engineering type approach to this.
Yes.
Yeah, crapulence actually just means hungover.
Oh, okay.
Yeah.
So you're feeling it? You're feeling crapulence?
Yeah.
I can see that.
I've never heard that before, but
me neither.
You can use that now if you
next
if
time
you
I'm
need
hungover.
To. Yeah. All right, last one is snollygoster. What is snollygoster?
Snollygoster. It sounds like gossip to me. Like if someone's a snollygoster, like they've got the tea, like they've got the gossip. They're telling everyone. I'm picturing like mean girls in high school, like they're snollygosters.
Yeah, I like that one actually better than the actual definition. The definition that goes with this is an unprincipled politician.
Oh, okay. Similar. They can be mean girls.
Yeah. Well, I think some of your definitions beat the actual definitions, but
we'll
thanks for playing. We'll have them change them.
Yeah.
Well, these words are dead anyway, so nobody will use these. But all right. Well, did you have any final lessons, any final surprises that you learned on this project, either about science, the project, or yourself while doing this whole thing?
Yeah, absolutely. I think the biggest takeaway is to, when we're looking to solutions to some of these, really complex, integrated environmental, social, political challenges, to look outside your industry. One industry's waste is another industry's gold mine. So really looking outside, thinking outside of the box, and talking to people that you wouldn't normally to solve a problem. Because that's really, really what brought us to this. Cool.
Well, it sounds like it's very in line with the whole mission of PARC, the Pilot and Research Center here at South Platte Renew, is to kind of think outside the box and approach things maybe in a different way than they've always been approached. So it sounds like this project fits right in with that model.
Yeah, absolutely. I think, one thing we've been taught a lot here at SPR is that design thinking method, like really get down to the problem at hand and think outside the box for some of those solutions. And don't be afraid to test it. I mean, if anyone was like, we're going to use whiskey to test wastewater, the immediate response is probably like, no, that's not going to work.
Yeah.
But go ahead and test it out. And even if it fails, you're still learning from that opportunity.
Yeah, exactly. Well, good. Thanks for being here. And hopefully we can have you back and talk about some of the other PARC projects that you're working on. And we appreciate you being here.
All right. Thanks so much for having me, Blair.
All right. And to the listeners out there, thanks for listening. Thanks for watching the YouTube video. And if you have any ideas for guests or projects or suggestions for the podcast, you can send those to innovationflow@inglewoodco.gov. We're setting up an email just for the podcast, so you can email us there and get a hold of us. And we'll see you next time on the Innovation Flow podcast.